Hi, I'm Dan, a director here at MedTec Design Services. We've been supporting our clients at all stages of the design process for 40 years, by offering turnkey solutions from concept to creation. MedTech now has a focus on new technologies, such as 3D printing. We have been using Ultimaker printers for the past 4 years, and like many other businesses, due to COVID, we've had to think about the services we offer and how to adapt. We currently use our 3D printers in a few ways to complement our engineering services. Design reviews for our internal projects, small batch runs for clients, or a one-off print for our clients to review. Due to our client list, we felt it would make sense for us to broaden our offerings. 3D printing metal parts was discussed, and with a relatively small investment and low risk, we decided to construct a more detailed plan. We've heard about the metal filaments that we could use, but we were unsure about the processes involved with using them. Instantly, we found ourselves with a huge list of unknowns that we needed to get some support and advice on.
Metal additive manufacturing or 3D printing often comes with very significant running costs, very significant health and safety costs, and very significant other considerations to be able to make fully dense metal components using additive manufacturing. The stainless steel filaments made by BASF in both 316L and 174pH blends is an ideal way to get involved with this method of metal additive manufacturing. And together with the print material profile generated together with Ultimaker, makes it relatively straightforward to start 3D printing metal parts. You just need to ensure that you've got the correct hardened steel nozzle to print with these materials and the correct bed adhesion, and you're good to go in terms of 3D printing. What you do need to consider though is the next stage, which is post-processing of the parts through what's called debind and sintering. That's a two-stage process. The first stage is debinding, where the polymer content in the filament is actually taken away, leaving just behind the metal powder. That then leads to the second part of the process called sintering, where that metal powder is fused together to a final part that is 96 to 98% dense. The other thing that you need to understand through the debinding and sintering process are the limitations that you have on the design and the 3D printing of the parts that come before it. That means understanding things like part shrinkage, wall thicknesses, density, overhangs, and all of those kind of considerations to ensure that you can get to a successfully post-processed part. So in understanding each part of the process, you can get to a successful metal 3D printed part like this one that can be made on a desktop printer like the one beside me.
After knowing to beware of some of these potential issues, we're nearly ready to set the print off. We must make some tweaks to the settings in our Cura software, as the model has to be scaled up to allow for shrinkage during the finishing processes. In Cura, we need to scale the part up by 20% in the X and Y axis and 26% in the Z axis. We also have to use the material profile called UltraFuse 316L. We're now at the point where we are ready to get this print underway. Let's see how this pans out.
So we've assisted MedTech in preparing their part for successful 3D printing. They've now 3D printed it, and it's gone away for post-processing with our post-processing partner, and we'll see how that turns out.
Once customers have bought the filament and printed their components are then sent to us here at CMG Technologies to carry out the final stages of turning the printed part into a solid metal component.
Hello there, I'm Phil Grimmer from CMG Technologies. Currently we're working with 3D GBRE and MedTech on a new component which has been 3D printed, as shown behind us. This big component here, currently it's up to debind stage. It's been printed, and all we've got to do now is process it through our debind oven. This oven here is a Kramer catalytic debinding oven. And basically what that does, it removes the acetyl, the backbone of the binder system within the product itself. once it comes out, then we'll be on to the sintering side. While the part is in the oven, we have to gauge how long it's got to stay in the oven for, and generally the rule of thumb is 1 millimetre per hour. So it's got to be, so if the part was 10 mil thick, it may have to stay in the oven up to 10 hours with acid being drip fed into the oven. So one thing we've got to mention is the shrinkage. This component was designed with a 20% in the X and Y and 26% in the Z. So if you can see as I'm holding up, there's quite a lot of difference. So that shows what's happening at the shrinkage side of things once it's been sintered. So obviously during debind it holds its same size and shape. That's very important at the catalytic debinding stage. And as it sinters and it gets past 1,000 degrees, it then starts slowly shrinking down to its final size. Okay. Now our part's been fully debound, it's ready for sintering. This is our sintering furnace. It will sinter the component down to a very high density. Generally it takes about 8 to 10 hours for that process to fully finish. It will basically, the sintering furnace, it will go into vacuum and to pump all the air out, and once that's been completed it will slowly warm up, and then it will add hydrogen along the way. So it will then go into a very kind of low, just above the atmospheric pressure of hydrogen, a hydrogen blanket. So as that carries on, it will take little steps. It will go up to 600 degrees and then we'll carry on going up to about 1360 degrees for this 316L component to be fully densified, and then it will slowly cool down over a few hours.
So the part that MedTech have 3D printed has now been returned to us back from CMG Technologies, who've carried out the debind and sintering process. The part that's come back has been very successful. You can see here the setter that was created to actually aid the stability of the part through the debind and sintering process. And you can see we've got to a very successful final part that, with just a small amount of polish, has actually produced what you see in my hand. So we're now going to send this down to MedTech for them to share with their customer, and we can see it in the final end application. So if you've got an application that you think could benefit from metal filament 3D printing, get in touch with us at 3D GBIRE and we can take you through the entire process in a consultative manner.